Next on Energy Switch, we'll look at air pollution from energy and how we could reduce it.
About 2.4 billion people still use solid fuels: wood, animal dung, coal, charcoal, and other biomass. Indoor and outdoor air pollution combined kills still about 7 million people.
Particulate matter pollution is the fourth leading risk factor for death worldwide. And so it's the #1 environmental killer. And the fact is that there aren't universal standards for air pollution reduction. And as a result, you have a lot of countries that are doing different things. They're betting on certain technology winners as opposed to really thinking about, well, what is the goal that we're trying to establish?
Coming up on Energy Switch, energy impacts on air.
Funding for Energy Switch was provided in part by the University of Texas at Austin, leading research in energy and the environment for a better tomorrow. What starts here changes the world. And by EarthX, an international nonprofit working towards a more sustainable future. See more at earthx.org.
I'm Scott Tinker, and I'm an energy scientist. I work in the field, lead research, speak around the world, write articles, and make films about energy. This show brings together leading experts on vital topics in energy and climate. They may have different perspectives, but my goal is to learn and illuminate and bring diverging views together towards solutions. Welcome to the Energy Switch. CO2 emissions from energy get most of the attention, but there's a more immediate threat. Particulate air pollution from burning coal, wood, and other biomass, and diesel kills more than 7 million people each year, mostly, but not solely, in developing countries. In this episode, we'll look at air pollution from energy and ideas to reduce it with my expert guests, Dr. Angel Su. She's an assistant professor of public policy and environment at the University of North Carolina and founder and director of the Data-Driven Enviro Lab. Her research focuses on coal use in China and the Global South. With her is Dr. Amod Pokhrel from the School of Public Health at the University of California, Berkeley. For more than a decade, he's been studying the impacts of biomass cooking in Nepal and India and the transition to cleaner options. On this episode of Energy Switch, the environmental impacts of energy on air.
Let's just get right into it. What is particulate matter air pollution? What does that mean?
Particulate matter pollution is a class of particles that can be very coarse, like dust in natural sources, sand, for example, or they can be incredibly small and microscopic. And so one class of particulate matter, PM2.5, are released into the atmosphere when we burn fossil fuels, we drive our cars, we have industrial processes, agriculture, and they can be less than 1/30th the diameter of a human hair. So incredibly small.
Okay, and PM2.5, is that particulate matter, and 2.5 is like?
PM2.5, that's the diameter that we're talking about. So it's 2.5 microns, so that's micrometers or less.
And you've worked with particulate matter and a lot of the things you're doing, Amod.
Yes, so I mainly study the particulate matter that comes from burning solid fuel. About 2.4 billion people still use solid fuels: wood, animal dung, and then coal, charcoal, and other biomass. Biomass fuel could also be 1 micron size, ultrafine. So
1 micron?
Yeah.
So PM1.
PM1, and also there could be ultrafine particles matter that are 100 nanometer size.
How do these things affect the body? What are some of the different kinds of responses to particulate matter like this?
Indoor and outdoor air pollution combined kills still about 7 million people. Mm-hmm. So it's a combined effect. It could increase the risk of asthma. It could increase the risk of cardiovascular disease, stroke. And the study that I've conducted, I found exposure to biomass smoke also increases the risk of cataract. It could increase the risk of tuberculosis. And dangerously, if children are exposed to particulate matter, especially in the indoor setting, like in developing countries, they could also get pneumonia. And then pneumonia is a major killer of children in developing countries. So yeah, it can cause so many health effects.
Particulate matter pollution is the fourth leading risk factor for death worldwide. And so it's the #1 environmental killer. And so the only other risk factors that cause more death would be tobacco use, high blood pressure, and also your diet. That translates into 12% of global deaths, So it's absolutely devastating. And I think what's really surprising, so I study cities, people who are living in cities like London or Paris or New York. We go outside, we're seeing blue skies, and we don't necessarily think that air pollution is a problem. So it's frequently been referred to as a silent killer because you can't perceive PM 2.5 particles or these ultrafine nanoparticles that Amod was speaking of because they're so small, they're invisible to the human eye. And so more than 90% of people, the World Health Organization has found, is actually living in cities that exceed their recommended levels for safe exposure to PM 2.5, although I take some issue with that designation because any exposure to PM 2.5 or particulates, as Amod has shown, is not safe for human health.
So let's start to dive in a little bit to how do we see coal producing air pollution?
In China, especially, how many households still use coal. And then studies have shown that people living in those households had a very high risk of lung cancer.
Yeah.
Sorry, Scott, if we could stay on China, for a little bit longer. I mean, it's not just cooking. I just wanted to add, it's also electricity. More than 60% of China's electricity is being generated through coal combustion. And that's particularly polluting for the air.
China burns more coal now than the rest of the world combined.
That's right.
But it's affordable, it's available, it's reliable, it's lifting them out of poverty. So there's this real weird trade-off going on between health and then affordable energy. There's this tension.
Yeah, exactly. But I mean, I think that the Chinese government is aware of this tension. And when I was living in Beijing, I lived there from 2008 until 2012. The air was incredibly polluted. I mean, there were days where I didn't see the sun. You literally could not even make out features in the sky. People started to also recognize that they were getting sick. So China, in the overall picture, 1 million premature deaths every single year due to outdoor air pollution, and particularly that PM. And so realizing that's one of the reasons why the government has put in policies now to really try to reduce the percentage of coal in their overall energy consumption. And it has. I mean, you look at major cities in China, Beijing, Shanghai, they've really been able to decrease pollution, air pollution in these cities because they've been switching away from coal, increasing the amount of renewable energy, and also switching to natural gas.
Yeah. What are some of the things we can do to the coal plants themselves to actually start to reduce some of the particulate matter and other kinds of emissions?
In the U.S. context, what we've done through the Clean Air Act is to install scrubbers on more than 70% of coal-fired power plants in the United States. And so that's really helped to reduce sulfur dioxide emissions. Of course, it doesn't help with the carbon emissions that are still generated, but at least in the United States context, that's been hugely effective in reducing air pollution. And then there are things that you can do in terms of washing the coal and trying to make the sulfur content lower in different types of coal. I mean, I just feel like all of these are just Band-Aids over the real issue, which is that we just have to move away from coal.
What are some other options? You mentioned natural gas. I mean,
when you combust natural gas instead of coal, then you're not putting PM and NOx and SOx and other pollutants into the air, but you're still emitting CO2. I think now, if we look at the economics, since 2010, the cost of wind and solar power has decreased by 85%. So these technologies are now much more cost competitive, and then if you factor in the health impacts, then it just doesn't add up.
Right. Amod, in your studies, particularly indoor cooking studies, you've seen the effects of this. Talk more about that. Some of the things that could be done for a couple billion people, right, who still cook indoors.
Yeah, so to really bring the air pollution level or exposure level to the 10 microgram per cubic meter or even 20, you really need an electric cook stove or LPG or biogas, that kind of for developing countries. So we did this behavior change campaign. We measured blood pressure on women who are cooking on different stoves before, so that if they use more clean fuel, then their blood pressure level would come down. And then later, we also introduced electric cook stove because Nepal is rich in hydroelectricity. There's a target to electrify all homes by 2030, and we found that introduction of induction cook stove indeed decreased the use of LPG and biomass stove, and it helped improve the health.
Interesting. Yeah. What are the different kinds of biomasses people use globally? And again, we're talking about 2 to 3 billion people here. It's not just 100 million somewhere. This is 2 to 3 out of 8 billion people in the world now still cooking this way.
2.4 billion people approximately using solid fuel for cooking as well as heating, because heating is important source.
Right.
It depends on country what kind of solid fuel people use. In Africa, most of the households use charcoal. And in China, as I said, that households use wood as well as coal. People in Nepal, India, people use biomass, different biomass, and also many households use dung, animal dung. They just dry in the sun and then burn it, and that emits nasty smoke and other pollutants.
Yeah. That's not the kind of circular economy we need. Dung is not the thing we want to be cooking with.
Yeah, and in many other parts of the world, people also use crop residue. In some part of South Asia, solid fuels are also used to prepare animal food. So for the last 10 years, we were focusing only on this indoor cook stove, but we realized that because even if we introduce like a cook stove in the kitchen, if households have animal, then they make animal food, and they're exposed to, again, very high level of air pollution.
And if I could just take it into a little bit of a different direction, I think a theme of this conversation, these tensions between air pollution and climate change, where when you focus on one goal, then you have a tendency to exacerbate the other goal. And so now biomass is actually being talked about as one of these net negative electricity technologies. And so you could be using inputs like crop residues, for example, as a feedstock, generate electricity. There's been a little bit of a walk back from that because there's still air pollution concerns. There also could be competing uses for crops, potentially depriving people of food or lessening food production in some areas.
I love what you're saying about if you push too far, whether it's air quality or atmospheric emissions or land use.
Right, that's something we haven't talked about, which I feel like is the big elephant in the room with respect to biomass. In Southeast Asia, where I was most recently living, there was incredible haze that percolated from Indonesia and Southeast Asia because of biomass burning from agricultural practices, slash and burn, but then also from peat fires. But also from peat fires. Those are huge stores of biomass that were burning, and then all of that pollution was being blown into Singapore. I mean, it was just incredible. It just impresses the point that air pollution is not just contained within a certain set of defined point sources. It's actually a regional and even global problem where if you've got biomass burning, I mean, they've done these studies in California where they've been able to trace the pollution from China in California airspace. And so this is a really big issue.
Right. What are the options to biomass?
For developing countries, I would say that rather than drying dung in the sun and then burning it in the stove, the biogas system could be introduced. Households could put dung in the digester system and then generate gas, and then use that gas to at least prepare a meal. It may not be sufficient, but at least it would provide some clean energy.
Right.
But you have to be very careful because to use biogas, the households may have to interact with the dung, and then dung and animal waste also have bacteria. And we found that there's an unintended consequence of getting diarrhea.
Yes.
For wood, also, there are some stoves available, like high tier 3, tier 4 stoves. Although the challenge is that these stoves are very expensive. The technology is there, but it's very expensive. Liquefied petroleum gas is the best alternative for countries who can afford it. Like in India, there's a massive growth of LPG going on. So many households are now replacing wood stove with the LPG. But for countries that import LPG, that may not be an option. So we need to find a local solution that works best. And then I think some kind of energy mix. For heating, mainly rather than just using wood, there could be a bed heating system. Like in Korea, in Japan, many households heat or put electric quilt, a blanket.
Interesting.
Those kind of smaller technological interventions could be introduced to address this cooking and heating challenges associated with the biomass.
Right. None of them necessarily perfect. But perfect can't be the enemy of a heck of a lot better than what they have in poor countries. How much of the cultural component do we need to focus on in order to get change to happen? Because these things are deeply embedded.
Yeah, so households are cooking, on biomass stove for like thousands and thousands of years. So why this thing is not happening, in my opinion, is that biomass is available free. They can collect and then use in the rural setting. And also, people are so acquired with the taste. There's a perception that it tastes better. And also there's a perception that the modern cooking fuel are expensive. It may or may not, depend on the country. But if you could make them aware that these are cheap, there are health benefits from it, and climate benefit, environmental benefit, maybe a household would switch.
Yeah, so a combination of things. Cost and culture, adapting the technologies, and then showing comparisons that, it's not different.
Well, this seems like an obvious place for government to step in and try to subsidize the cost of these technologies in order to help the adoption, right? I mean, are the governments not involved? Like, I don't understand.
I think in many countries, government is involved thoroughly. Like in India, government is involved in promoting LPG. It's providing free LPG cylinder for 1 or 2 times, and then free stove to people who are really poor. In Nepal, some local governments are providing electric cook stove free of cost.
Okay.
I don't know whether that's sustainable or not. Interestingly, government in many countries are providing subsidy to LPG, but not to electricity-based cooking. So now government has started introducing some subsidy for electricity-based cooking. So there is a threshold, like there's a lower tariff for electricity up to 20 kilowatt hours of use. But if a household use more than 20 kilowatt hours of electricity, then the cost become prohibitive. There's a very expensive. So what we noticed that households were using only electricity for cooking up to 15 kilowatt hours. And after that, they thought, maybe we reached that threshold, and they switched to biomass cook stove. So we are saying, we tell government that, if we could increase this threshold, like 50 or 100, then household would use electricity for cooking.
I mean, that's the way that it's worked in the developed world in terms of renewable energies like solar and wind. I mean, there are feed-in tariffs where the government was subsidizing the cost for consumers, and so then it would be cheaper. And so, I mean, now, not as necessary. I mean, China just recently got rid of their feed-in tariff for solar power because now the costs have really fallen. But it seems like that would be an easiest and obvious policy that governments could implement to encourage the adoption.
Yeah.
And another interesting thing we noticed was that, I just got back from Nepal again, government has provided free electric cook stove to students from outside remote areas. And then they want to see whether students could be a change agent, whether uptake, that would help uptake the electric cook stove or clean fuel stove in their community. So this is experiment. We are doing this research to actually see if that works. If it works, then there could be an option for promoting the stove through different ways.
Oh, that's great. Let's talk about diesel. I mean, I see the cars going down the street. I see the black cloud. What do we got there with diesel?
One of the arguments for using diesel is you get more bang for your buck in terms of energy content, that you can actually be more CO2 efficient by running a diesel engine that burns diesel fuel as opposed to gasoline, which is lighter. But then also, as a result, you get these air particulates, really bad sulfates, nitrates, nitrogen oxides, and those really pollute the environment in a very dangerous way.
Yeah, also, I'd like to add that diesel emission also include ultrafine particles. It's very tiny particles, and that increases the health risk a lot.
Right. Lots of trade-offs going on. Where's diesel most damaging? Where can we start to improve that the most?
Trucking, like transportation. In most of the transportation system, diesel fuel are used. Then cities, urban areas, diesel is a big problem.
So options for fuels that aren't diesel for transportation. Is there anything we can actually do to the diesel engine itself to clean it up?
The state of California have put in vehicle emission standards to make sure that the diesel engines are burning cleaner, or they have technologies to try to remove the NOx and the SOx before it's emitted into the atmosphere. But like all these other technologies, it actually can require more energy. I look at what happened in Europe with VW, the whole scandal that emerged in 2015, where their technology was actually lying in terms of the emissions that were being generated from diesel cars.
Are there examples of where it's being done well in emerging or developing economies? Who's doing it better that others could follow?
Many developing countries are following this Euro standard, like Euro 5, Euro 6, Euro 7, and that's the diesel standards. What I'm seeing lacking is there's no test, like compliance test, whether that's really emitting less pollution. Right now, they're just importing and then using it.
And I think China is a really great example of where they very early on adopted the Euro 5 and the Euro 6 standards, and it was hugely effective. And I don't think it's expensive, actually, to implement those particular policies. I mean, it's pretty cheap to try to remove some of the sulfur content from diesel fuel to make it burn cleaner. But I think what China has also done within cities is that they had a system of yellow carding certain vehicles. If they don't meet these emission standards, then they're yellow labeled, and then they give cities certain targets for reducing the number of yellow labeled vehicles every single year until all of the cars meet those very stringent Euro 6 standards.
Yeah.
And one of the things they've also done is made it incredibly cheap and subsidized for consumers to purchase electric vehicles.
What prevents these things from being adopted faster into the system?
I mean, in the social science literature, so I'm a social scientist, we talk about lock-in. What a lot of governments and countries decide to do when they embark on these challenges is to adopt a particular technology. And that can lock you into a certain path for decades to come. We talked about coal-fired power plants. Some of them can last as much as 60 years. It's the same thing with vehicles or trucks. And in the case of Europe, I mean, they were thinking about this from a climate change perspective, and they said, we're going to put in policies to make diesel cars cheaper than gasoline cars. And this is the way we're going to go. And they weren't betting on how difficult the air pollution knockoff effects would be. And so when you try to then reverse engineer a problem that you caused by trying to address the climate change issue, then it becomes really expensive. And they realized it was actually much harder to try to get the NOx out of the air that was being generated from diesel vehicles. And so that's why air pollution is still an incredibly difficult problem in London. NOx pollution is incredibly bad, and in other parts of Europe where they decided to favor the diesel vehicle.
What do? Do we set the standards then? Instead of trying to pick these winners,
yeah, exactly.
What do we do?
What I think needs to happen is that we need to be thinking about what the goals are. And the fact is that there aren't universal standards for air pollution reduction. And as a result, you have a lot of countries that are doing different things. They're betting on certain technology winners as opposed to really thinking about, well, what is the goal that we're trying to establish? And then as a result, in cities, 90% of people in urban areas are exposed to unsafe levels of air pollution.
Right. Let's talk a little bit about data. How can data, access to better data, help us improve a lot of the things we've been talking about today?
So I would like to give an example from my own study. So what we found was, we provided electric cook stove, and then households were not using electric cook stove for a long time. So they were using for 15 days and then stopped using it because they thought they crossed that threshold, subsidy threshold. So we provided a visual app where they could see how much electricity they have consumed and how much electricity is left. And they said, oh, well, I still have a 5 kilowatt hour left. I can use it. So that visual data, graph and numbers help them to use more electricity.
Interesting.
And then reduce the exposure.
That's fascinating.
Yeah, and then, I think scaling up too and going to the government level, governments absolutely need data to understand where is air pollution the worst, who is it affecting, and are our policies to address them actually making a difference? And frankly, in terms of global air pollution data, it's appalling how little governments actually invest in air quality monitoring. If you look at the World Bank and the World Health Organization, they publish a database of all public government ground-based monitors.
Right.
The entire country of Russia, can you guess how many monitors they have? No. There's one for the entire country. There's one. And it's just completely shocking that this is an issue that is resulting, we said 7 million lives every single year, and yet governments are not collecting data. And to make them open and public so that consumers, we can incorporate them into our smartphones, we can understand whether or not we should go outside and wear a mask to protect us, and for governments as well.
Final thoughts, particularly kind of the 3 most important things that each of you see that we could do to reduce human suffering from each of your perspectives. Start with you, Amod.
We could really, help save millions of lives if air pollution level is reduced, both indoor and outdoor. For indoor air pollution, those reduction could be done by introducing cleaner fuel technology, by providing cleaner appliances. We need to work on technology, make them cheaper, so that rural as well as urban poor could also afford those technologies. And also data would be needed to make people aware, to change their behavior.
Win-wins.
Win-wins
in many ways, yeah.
Well, I think Amod said more than 3. I feel like it's a lot of really good stuff.
He grabbed them all.
I know, so it's hard for me to add. But I would say, number 1, just moving away from coal as a primary electricity source. I think that would be really huge.
Right.
And then I think in talking about these climate change and air quality co-benefits, I think we need to stop picking technology winners and thinking about setting those standards and then, again, collecting data to then evaluate, are we actually meeting those standards, and helping to establish these global goals for air pollution reduction. I think that would really go a long way.
Absolutely. Lots of challenges, but a lot of neat things being done too. Progress is being made, so thanks for sharing your insight.
Thank you so much.
You bet.
Thank you
Thanks.
very much.
Thank you.
Indeed.
Particulate matter air pollution, or PM, leads to millions of premature deaths every year. PM pollution is mostly a problem in the developing world. In urban settings, it comes largely from burning coal for power production and diesel transport. In rural areas, coal for heating is a problem. But there, most PM pollution comes from cooking. Solutions to these problems are not easy. Cleaning up or moving away from coal for power and heating, and moving from biomass cooking fuels to liquefied petroleum gas, biogas, and electricity. Local governments can help with subsidies, but their funds are limited. In my view, to improve the lives of billions of people, we in the developed world could help them transition to lower emitting sources.
Funding for Energy Switch was provided in part by the University of Texas at Austin, leading research in energy and the environment for a better tomorrow. What starts here changes the world. And by EarthX, an international nonprofit working towards a more sustainable future. See more at earthx.org.